How do we tell different kinds of matter apart? And we looked at this a little bit in lab last week. Physical and chemical properties. So a physical property is one that a substance displays without changing its composition. A chemical property is one that a substance displays only through changing its composition. So physical property is something that you can measure or observe, and it doesn't change the composition of the substance. Now, it could change its appearance. You can melt an ice cube, and that demonstrates a physical property of water, that it melts at 0 degrees Celsius. Does the water look different after you melt it? Sure it does. But are the particles the same? Yes, it's still water. That's a physical change. A physical property, I mean. So a chemical property of water is that if you pass electric current through it, it forms oxygen gas and hydrogen gas. When you demonstrate that, perhaps by putting a 9-volt battery in a glass of water. Did anybody try that? No. Probably not good for the battery. But you put a 9-volt battery in a cup of water, and you see bubbles forming. And it's decomposing the water into hydrogen and oxygen gases. We have now changed what the substance is. We've demonstrated a chemical property of water, but in doing so, we destroy the water. We change the composition. So the characteristic odor of gasoline. Gasoline has that real distinctive smell, right? When you smell the gasoline, do you change what it is? No. That's a physical property. Gasoline is flammable, right? That's why we put it in our cars, because we need the little explosions to move the pistons. The flammability is a chemical property. When the gasoline burns, it's not gasoline anymore. So the composition changes. So the atomic or molecular composition, what the individual particles are, doesn't change when we display a physical property. So here at the boiling point of water, I mentioned freezing and melting before, but the boiling point of water is a physical property. When you boil the water, it changes from a liquid to a gas, but the particles are the same. Yeah, this section is just really repetitive. We'll just look at the picture here. So here are our little Mickey Mouse head water molecules. In the liquid, they're very close together, touchingly close. And when we apply heat to this, we cause it to boil and go into the gas state. And now the particles are farther apart, but they're still little Mickey Mouse heads. So it's still water. That's a physical property, that it boils at 100 degrees Celsius. I think we all know that iron rusts, right? You leave a piece of iron outside, you'll leave your dad's wrench outside in the rain, and it gets all rusty and nasty, and then he gets mad. That is a chemical property of iron. Here we have an illustration of a nail, and the nail is composed of iron atoms. When that rusts, we get oxygen incorporated into the structure of the iron. This is a chemical property of iron, that it rusts. And when we demonstrate the property, we change the iron. Is rust as strong as iron? No. Rust is all flaky and it just falls apart, right? And eventually, whatever object it is, just like it disintegrates, because the rust forms and then it flakes off, and then more iron is exposed, and that rusts and that flakes off, and pretty soon your nail is gone. So we should be able to do something like this: determine whether each property is physical or chemical. The explosiveness of hydrogen gas, that's a chemical property. When we demonstrate that, we don't have hydrogen gas anymore. The bronze color of copper, That's a physical change. We can observe, not a change, physical property. We observe the color, does nothing to the composition of the substance. The shiny appearance of silver, physical. The ability of dry ice to sublime. And when we say sublime, we mean that it changes directly from a solid to a vapor. That's why it's dry ice instead of wet ice. Regular ice, when it melts, right, and gets everything wet. Dry ice doesn't do that. It goes directly from the solid to the gas state. Physical property, chemical property. It's a physical property. State changes, anything to do with melting, freezing, condensing, anything like that at a particular temperature, or just its ability to do that, does not change what the substance is. And so those are all physical properties. Any questions about this one?